I want to kind of recap what we talked about yesterday. We talked about all of this yesterday, but whenever you guys did your homework, we stopped and we just did the axis of symmetry and vertex. So let's remind ourselves of that. So we're learning how to graph parabolas, U-shaped curves. We want to find the vertex first, but before we find the vertex, we are finding the axis of symmetry, that vertical line. So the formula to find the axis of symmetry is x equals the opposite of b over 2a. So remember, the a and b come from the ax squared plus bx plus c. You have to pay really close attention, especially with the b. The b is numbered in front of the x. If you don't have an x term, your b is 0. Okay. Now, once you plug in those numbers, so the opposite of b over 2a, so 2 times 2, we get -1. That's your x. X equals -1. That's your vertical line that cuts your parabola in half. But furthermore, that's what the x is for your vertex. So you're going to plug that into your function to get out your y. That's all we did on our homework yesterday. Found the vertex, plug that number into the function to get the other half of the vertex. Okay? We did talk about through this example yesterday, and we said, okay, once you find the vertex, you can plot the vertex, and one thing we're going to find out is that I actually know without graphing it if the graph is going to open up or down because of whether A is positive or negative. If A is positive, it's going to open up, like we saw this one here. If A is negative, so one of the ones we'll look at in our examples is negative, it's going to open down. So just knowing the vertex and knowing if A is positive or negative, you're going to have a pretty good idea of what that graph looks like. But if you want to know exactly what it looks like, we need more points to plot. So if we start at the vertex and we go to the left, we're plugging in x values. So if I start at the vertex of -1 and I go to the left, I'm at -2 and -3. So those are the numbers you're plugging into your table. And then if you go back to your vertex, -1, and go to the right, 0 and 1, okay? These are the numbers you're going to plug in on the other side of the table. Okay. So, this one we started yesterday. Okay, so we have the axis of symmetry, x equals the opposite of b over 2a. Okay, and then we plug that -1 in here, -1 squared minus 4 times 1 minus 5, and we got out -8. Okay, so that's what we did yesterday. Now to finish it today, what you're going to have to do in your homework today is we need to find those other points. So we're going to fill out our table. So in your table, remember the middle of your parabola is your vertex, so the middle of your table should be your vertex. You're always going to take that vertex, plug it into the middle of your table, that 1, -8. And then you're going to fill in the numbers around your vertex. So if your vertex is at 1 and you want to go to the left, it would be at 0 and -1. And if I go back to my vertex and I go to the right, I would be at 2 and 3. So really the only thing you're doing today is you're plugging these 4 numbers in. And actually, we don't have to plug all 4 of these in because if you guys remember from what we talked about yesterday and what I mentioned right now, I know the vertex is right there. A is positive, so I can tell you right now that this graph is going to go through that vertex and it's going to open up. I already know that, but if I want to know specifically what it's going to look like, I need more points to plot. But remember, parabolas are symmetrical. So I can already tell that if you start at your vertex and go 1 step to the right and then 1 step to the left, you're going to get the same thing. You don't have to plug in both 0 and 2. I promise you're going to get the same thing. So if I were you, I would probably plug in 0, because 0 is super easy to work with. So remember we talked about yesterday, this is the function machine. These are the numbers you're dropping into your function machine. This is your rule. It's going to spit out a y value. So to find out what y equals, when I plug in 0, we are going to take 0 squared minus 4 times 0 minus 5. 0 is super easy to work with because 0 squared is 0. 4 times 0 is 0. 0 minus 5 would be negative 5. So when you plug in 0, it spits out negative 5. I promise you, if you don't believe me, you can totally plug it in, but I promise you if you plug in 2, you are also going to get out negative 5. Because if I go to the right of my vertex and I get negative 5, I should get the same thing as when I go to the left of my vertex. I have to get the same thing for it to be symmetrical. If they were at different heights, your parabola wouldn't be symmetrical anymore. Okay? And then we would do the same thing here, that you don't have to plug in both negative 1 and 3, because I promise you, you're going to get out the same answer either way. Negative 1's a little smaller. 3 is positive. Let's plug in negative 1, because the negatives tend to be the ones that students struggle with maybe a little bit more. So if I plug in negative 1, you are allowed to use your calculator today, but I'm having a lot of students who are having a hard time plugging things into their calculator. So let me show you exactly what you're going to do. Okay, you're going to take y equals, we're plugging in negative 1. So wherever you see an x, you're going to plug in negative 1. So my rule says to take x squared. So if x is negative 1, you are taking negative 1 squared. The whole thing, not just the 1, you're squaring the whole thing. So you have to use parentheses when you plug that in. And then you're going to do minus 4 times negative 1. Once again, I just really strongly recommend you use parentheses when plugging in numbers, especially if they're negatives, and then minus 5 at the end. If you're using a calculator, you can plug that into your calculator exactly as you see it. Make sure you use the parentheses. If you're not, you're going to do order of operations. Negative 1 squared, a negative times a negative, is a positive. Okay, right here, it's really a negative 4 times a negative 1. Negative 4 times a negative 1 would be a positive 5. And then if I subtract 5, okay, 1 plus 5 is 6. And 6 minus 5 is 1. So when I plug in negative 1, I get out 1. When you plug in 3, you are also going to get out. Oh, what did I do? Hold on. Nope, that's wrong, right? See that? There we go. Negative 1 times 4 is 4. There we go. 1 plus 4 would be 5. 5 minus 5 is 0. Okay, I knew something was wrong. So when you plug in negative 1, you get out 0. And I promise you, when you plug in 3, you're also going to get out 0. And then if I plot these ones, we would have negative 1, 0, and 3, 0. Once you have your points, you can connect them. Remember, it's always going to be a curve. It shouldn't ever come to a point like a V. It should always be a curve. That's all we're adding today, is you're going to have to find those additional 4 points. Okay? And let's try this last one that we put in your notes. Now for this one, we already found the axis of symmetry. So this is the one where I said you have to be really careful to find the axis of symmetry. We're going to do the opposite of B. But if B is the number in front of your x term, this is one where I don't have an x term. If you don't have an x term, your B is 0. So it's going to be 0 over 2 times negative 1, which is just x equals 0. When we plug 0 back in here, you get negative 0 squared plus 4, which is just 4. So your vertex is at 0, 4. Now, before I even plug in any other numbers, notice here how A this time is negative. That means that this parabola, this one's going to open down. Now, I don't know exactly what it's going to look like. I don't know if it's going to be like a narrow graph or it's going to be super wide. I need some more points to help me decide that. But I do know it should open down. Okay? So we found the vertex. You're going to take that vertex, and remember, you're going to plug it, I'm sorry, a positive 4, you're going to plug it into the middle of your table, 0, 4. And then to fill in the x values, you plug in the numbers around it. So if you start at 0 and go to the left, you'd be at negative 1 and negative 2. And if you go to the right, you'd be at 1 and 2. And then remember, you don't have to plug in all 4 of these. 1 to the right right and 1 to the left of the vertex, I promise you will get the same thing. So you can either plug in -1 or 1. 1 is probably going to be the easier one here. Now, you have to be super careful with this one, okay? Because my rule says you're going to take negative x squared plus 4. And if you're following order of operations, the first thing you have to do there is the exponents. But the only thing you're squaring is the x. You are not squaring the negative sign. The negative sign is still going to be there. So when you plug in a 1, y equals, my rule says that we're going to take x squared, so 1 squared, but that negative is still going to be there. And then we add 4. So we square the 1, and only the 1, and we get 1. That negative is still there, so it's going to be -1 plus 4, which is 3. So when you plug in 1, you get 3. When you plug in -1, you are also going to get 3. And then we do the same thing here. You could plug in either -2 or 2. You'll get the same answer either way. 2 would probably be a little easier just because it's positive. But remember, same rule here. My rule says whatever x is, so 2, you're going to square it, but it has a negative out front, then you're going to have 4. So we're going to take 2 squared first, which is 4, but that negative is still out front there, so it's actually -4 plus 4, which gives you 0. So we have -2, 0, and 2, 0. And if we plot all of those points, we should notice that it is going to open down